Hey guys, so we are into week 4 of our distance learning, and we're going to be focusing on polygons mostly today. So a couple little vocab terms to get us started. The first one is just what is a polygon, and it is a simple closed figure formed by 3 or more line segments. And we just call those line segments, we would just say sides, right? Formed by 3 or more sides. But it's important to say line segments because they do need to be straight line segments. So then underneath polygons, there's a more specific type of polygon, and that is a regular polygon. And this is a polygon, obviously it's a polygon, with all sides congruent and all angles congruent. Remember, congruent just means equal. So all the sides are equal, all the angles are equal. If you have that, then you have a regular polygon. So for just a normal polygon, that's what we have in this first set right here. In this first set of boxes, we have straight line segments, all being closed off, 3 or more sides. That's all you need to be a polygon. In the next one, we have regular polygons, because it's telling us I have 4 90-degree angles and 4 equal sides. All sides and angles are the same. For the triangle, the 3 sides are marked the same. The 3 angles are all 60. In this last one, this is a hexagon. All of the angles are marked being equal and all of the sides are marked being equal. So I know that I have a regular polygon versus just a normal polygon. Then the last set, these are not polygons. And the reason why they are not, this first one is not closed, has to be closed. This second one is curved, can't have that. And this last one, the lines intersect. We can't have that happening right there. Okay, so if it's not closed, it has any curved sides, so like a circle would not be a polygon. Okay, so not closed, curved sides, or the lines intersect, not going to be a polygon. Okay, next little thing to talk about is convex versus concave. A polygon is blank if a segment joining any 2 interior points lies completely within the polygon, versus a polygon is blank if it has a dent or a cave in it. Okay, so that should kind of help you to remember which one is which. So the first one is going to be convex. Segment joining any 2 interior points lies completely within the polygon. And then a polygon would be concave if it has a dent or a cave in it. So looking at this first one would be convex. This last one would be concave because of right here, it kind of caves in on itself a little bit. So that helps you remember that it would be a concave polygon. So now let's get into naming our polygons. Most of these you guys should know, but we are going to go through them quickly. So 3 sides would be a triangle. And if you want to try this on your own and then check, go for it. 4 sides is a quadrilateral. Don't say, let me write this first. Don't say square, don't say rectangle. It's just a quadrilateral, 4 sides. 5 would be a, I am blanking, a pentagon. Just had a moment there. 6 would be a hexagon. 7 is a heptagon. 8 is an octagon. 9 is a nonagon. 10 is a decagon. And then anything more than 10, we would just say an n-gon, and n is equal to the number of sides. So if it was 11, we would just say 11 gon, 12, 12 gon. There are names for some of them, but that just keeps it easier for us. And we're really not going to be getting into anything bigger than that. Okay? So now let's look at classifying polygons. For these 4 problems, we're going to first tell whether the figure is a polygon. If it is, We're going to name it by its number of sides, figure out if it's regular, and then identify if it's convex or concave. If it's not a polygon, we'll explain why. So this first one, is number 1 a polygon, yes or no? The answer is no. So I don't have to fill in these 3 boxes. But why is this not a polygon? Because it has curved sides. And we can't have that. Polygon will not have a curved side. Number 2, is this a polygon? Yes or no? Number 2 is a polygon. Yes. By the number of sides, we have 1, 2, 3, 4, 5. So 5 sides means that this would be a pentagon. Is this regular? Nothing is marking it to say that all of these sides are equal and all the angles. If you look at it, it doesn't look like it. So no, it is not regular. And then is it convex or concave? You can see that this one side here caves in, which means that this would be concave. And we can ignore the last one because it is a polygon. Number 3, is this a polygon? Yes or no? Yes, it is. By its number of sides, it has 1, 2, 3, 4, 5, 6 sides. So this would be a hexagon. Is it regular? Well, it's showing us that all 6 sides are marked equal and all 6 angles are marked equal. So yes, this is a regular polygon. Is it convex or concave? Nothing is being caved in. So that would be a convex polygon. And then we don't have to answer the last one. For number 4, is this a polygon? Yes or no? It is not a polygon. And why is it not a polygon? Because right here, it is not closed. It has to be closed to be a polygon. Okay, so the other 3 in the middle, you do not have to answer. Okay, so moving on. Now we're going to look at what is an interior angle. That is an angle that is inside the polygon. Okay, so that's an interior, and that's an interior. The sum of the interior angles is the sum of all the angles inside the polygon. So how do we know what the sum of the interior angles is of a convex polygon? These have to be convex to work. Okay, we would take, remember, n is the number of sides. So we do n minus 2, multiply it by 180. So you put in whatever the number of sides is, subtract it from 2, and then multiply by 180. Okay, that's how you can figure out what the sum of all of the interior angles are for any convex polygon. Okay, so find the sum of the interior angles. A quadrilateral has 4 sides. So we put 4 in for n, so it would be 4 minus 2 times 180. 4 minus 2 is 2, that's in parentheses, that's why we're doing that first. Times 180 means it would be 360 degrees. Number 2, we have 1, 2, 3, 4, 5, 6, 7, 8 sides. So then n is going to be equal to 8 here. So I'm going to do 8 minus 2 times 180. So that's 6 times 180. And 6 times 180 gives us 1080. So 1080 degrees. And let me just kind of check that quickly in my head. 600. Yep, that looks right. Okay. So that's how you can figure out the sum of all the angles. So all of those interior angles, all of these angles would add up to 1080 degrees. Okay? So now it's how do I find the measure of one interior angle of a regular polygon? And the only reason why we can do this for a regular polygon is because a regular polygon, all of the angles are going to be the same. Okay, you cannot do this for something that is not a regular polygon. Okay, so we're finding just one of the interior angles. We just found what the sum is, what they all add up to. Now I want to know what just one of them would be if I have a regular polygon. So I still keep that n minus 2 times 180. I still keep that. That's the sum of all of the angles. But then I'm going to divide that by n, by the number of sides that I have. Okay, because that's the number of angles that I would have. Okay. So find the measure of one interior angle for each of the regular polygons. So we can see that it's regular. All the angles are marked equal, all the sides. This is a hexagon, so n is going to be equal to 6 here. So for this problem, I'm going to do 6 minus 2 times 180, all divided by 6. So 6 minus 2 is 4 times 180. divided by 6. So bring this down here. 4 times 180 is 720 divided by 6 means that each interior angle is 120 degrees. Each one. That's 120, that's 120. All of them are 120. Okay? So then let's look at number 2, a regular nonagon. A nonagon has 9 sides. So this is going to be 9 minus 2 times 180, all divided by 9. So this is 7 times 180 divided by 9. 7 times 180 is 1,260. Divide that by 9. And we get that each angle would be 140 degrees. Okay, and again, this only works for regular polygons to find each individual angle. Next, we are looking at exterior angles. That is an angle outside of the polygon when you extend the side lengths. So it would be any of these angles. You extend the sides out, and it's the angles that are being made by the side of it and that extended side. So for any and all polygons, the sum of all exterior angles is always 360 degrees. It does not matter if it has 150 sides or if it has 3 sides. All of the exterior angles will always sum to be 360 degrees. So how do we find the measure of one exterior angle of a regular polygon? Again, only a regular polygon will this work for. So if we know that they all add up to 360, I'm going to take 360 and then just divide it by n, by the number of sides that I have. And that'll tell me what one exterior angle is of a regular polygon. Again, only reason why it works for regular is because we know that they're all going to be the same. So find one exterior angle measure of the following. So for a square, I know a square n is equal to 4 sides. So 360 divided by 4 is going to give me 90 degrees for each exterior angle. A regular hexagon, I take 360, I divide it by the number of sides, which is 6. 360 divided by 6 is going to give me 60 degrees. So one exterior angle is equal to 60 degrees. Last thing we're going to do here is classifying quadrilaterals. So a quadrilateral, we've already talked about this. It is just a 4-sided figure. Okay, so we have types of quadrilaterals. It first just starts with the most generic. We have a quadrilateral. Then it breaks into 2 categories. Over to the right, this is a trapezoid. Okay, if it's a trapezoid, that's all it is. Over to the left is a parallelogram. Now, if it's a parallelogram, you can keep getting more specific. And if you work your way down, to the left underneath parallelogram is a rectangle. To the right underneath parallelogram is a rhombus. And then all the way down is a square. Okay? And hopefully we know a lot of the qualities of each of those. Like a rectangle has 4 right angles, opposite sides are congruent. A rhombus, all 4 sides are congruent. And then a square has the 4 right angles and all sides are congruent. Parallelogram, opposite sides are congruent and parallel, things like that. Okay? Trapezoid, opposite sides are parallel. Hopefully we know that. Okay, so then let's getting down to numbers 1 through 4. I want you guys to go ahead and try these 4 on your own. Okay, so go ahead and check your answers against what I have. You can absolutely go ahead and pause it. Remember, you were supposed to label them, classify them in as many ways as possible. So not just the most specific, but all of them. This last one, finding angle measures. All angles in a quadrilateral, we should know this, they add up to 360 degrees. So we're going to go ahead and solve for x and then find each of the missing angle measurements. I'm going to go ahead and pause. I want you guys to try this, and then you can check your answers against mine in just a second. Okay, so again, you might want to go ahead and pause the video and actually check your work against mine, but you should have added up all the angle measures, set it equal to 360, solve for x should have been 59, and then plugged that in to figure out what all of the angle measures would be. So 121, 121, 59, and 59. Okay, So if you guys have any questions from the notes, you'll be more than welcome to ask me in the live meeting that we will be having very soon. See you guys soon.